3.2e. This is the last problem we're going to work on for this section. Example, let P of t equal 124 plus parentheses t minus 81, close parentheses, times e to the power of 0.02t, where t is between 1 and 52 inclusive. Find the intervals where P of t is increasing or decreasing. Find the critical value and the critical point. So the first thing we're going to have to do is find the derivative. So we find the derivative of P. Derivative of 124 is 0. The derivative of all of this, well, we're going to have to use the product rule, where we'll let this equal f of x and this equals g of x. So using the product rule, we're going to keep f of x the same, which is t minus 81. And we're going to multiply it by the derivative of e to the 0.02t. So we keep this the same, e to the 0.02t, and then we take the derivative of what's in the exponent, which is just 0.02. So that was the first part of the product rule. Now we're going to do the second part. We take the derivative of t minus 81, which is just 1, and then we multiply that by the second part, which is e to the 0.02t. So let's keep going. This goes away right here. We can just go ahead and rewrite this 0.02 t minus 81 e to the 0.02t plus e to the 0.02t. We can factor out our e to the 0.02 t, and we get 0.02 times t minus 81 plus 1. Now remember, this all equals 0. We're setting it equal to 0 to find our critical values. All right. Will this ever equal 0? This will never equal 0. E to the 0.02t cannot equal 0. All right. So we basically say does not exist at that point. Now how about inside here? If we set all this equal to 0, we're going to have 0.02 t minus 81 plus 1 equal to 0. 0.02 t minus 81, bring this to the other side, is negative 1. Get this by itself, divide both sides by 0.02, and we get negative 1 over 0.02. All right. Now we're trying to get t by itself, so we're going to add 81 to both sides. I'm going to write it over here so you can see it. Adding 81 to both sides, we get negative 1 over 0.02 plus 81. And if you put that into your calculator, you will end up with 31. All right, so what did we find? What is 31? 31's a critical value. So we found the first part. This is our critical value. Now we need to find our critical point. To find our critical point, we'll put the value into our original equation to find the y value, P of t. So we're going to put P of 31 into our equation. 124 plus 31 minus 81, e to the 0.02 times 31. Okay, and when we are done with that, which you can calculate on your own, it comes out to approximately 29.176. Okay, so our critical point is going to be 3129.176. That is our critical point. Okay, We're supposed to now find the intervals that where P of t is increasing and decreasing. So we're going to use our critical point, actually our critical value, and draw our little table with our interval. So here we have 31. So we're looking at intervals from 31 down to 1, because remember t we said was greater than or equal to 1 and less than or equal to 52. So now we're looking for this interval from 31 to 52. Okay, so let's pick some values. How about we just pick 2? 2 is an easy number to work with. So we're going to take the derivative and put in 2 into our equation. All right, so when we put 2 into our equation, you will find out it comes out negative. So we're going to put a negative there. It becomes a negative value. Over here, how about picking p prime of 32? And we put that into our derivative function. It'll come out to be positive, a positive number. Okay, so we can finish what we're asking for, which was where is it decreasing and where is it increasing. So it's decreasing right here on the interval from 1 to 31, and it's increasing on the other interval. And the other interval is from 31 to 52. All right, so do we have a relative minimum or a relative maximum? Here is our critical value, so we're going to have a critical point here. Is it going to be a max or min? Well, this is negative, so it's decreasing. This is positive, so it's increasing. We're talking about the slopes of the line. So yes, you're correct. That is going to be a relative min. Very good.